So one consequence of different types of solutions is electrical conductivity. So when I have an electrolyte, I can see some interesting things. So distilled water, we have no conductivity there. There's no ions. Now, if I have sodium chloride, but I just stick my probes into solid sodium chloride, again, nothing happens. But if I either melt the sodium chloride or I dissolve it in water and I split into ions, now I'm going to light the light bulb because I have conductivity. I have mobile charge. Okay? So to conduct electricity, you need mobile charge. And so my anions are going to go toward my positive electrode, and my cations are going to go toward my negative electrode. Okay? So here's a couple of others. Now, if you notice, this one is a strong electrolyte. So we have a nice bright light bulb. Okay? This one is a weak electrolyte. Okay, we have a dim. Okay? So if you notice, my strong electrolyte, I have ion, 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 ion. Everything's split into ions. My weak electrolyte, though, I only have a couple of ions, and everything else there is intact molecules. So some substances are only slightly ionizable, okay? Meaning that it will only split into ions a little bit, okay? Ionizable means that we can split it into ions. So we get strong electrolytes that are completely ionizable, and these weaker electrolytes that are only slightly ionizable. Some weak electrolytes only produce a couple of ions, some weak electrolytes produce a few more, but the result is that we don't have as many ions because some of the molecules stay as intact molecules. Okay, so here's a picture here. You can see this is what the hydrogen and the chloride ions look like. This is what the acetate and the hydrogen ions look like. And then this is what the acetic acid molecules look like. So when you look at these two pictures, the HCl here, the hydrochloric acid, is it a strong electrolyte or a weak electrolyte? And when you answer that, think about, well, do we have a lot of ions there or do we only have a few ions? If you're looking at this and you think there's a lot of ions, you're correct. So is that strong or weak? Well, it would be a strong electrolyte. Okay, here's our acetic acid. Okay, again, look at the picture. Do we have a lot of ions or just a few ions? Okay, here we just have a few ions. We only have those guys right there. So if I only have a few ions, is this going to be a strong electrolyte or a weak electrolyte? Well, it should be weak. Okay, so here's a few strong electrolytes and weak electrolytes. One big thing to point out here with our strong electrolytes is most soluble salts. So we're going to learn solubility rules in this chapter. And so if a salt is soluble, it should be a strong electrolyte because that means it will split up into ions. And then some other things that are listed here are some strong acids and some strong bases. And then on our weak electrolytes, we have some weak acids that are listed and some weak bases. Okay? And again, these are going to dissociate completely. And these are only slightly ionizable over here. And they do not dissociate completely. Okay?